Our next application of the derivative comes from this thing called point elasticity of demand. And if you've taken a microeconomics class, you're probably familiar with this formula. Point elasticity of demand is a measure of the decrease in demand for a 1% increase in the price. In other words, we want to know if we slightly adjust the price by 1%, we want to know how much the demand is going to change. The demand will probably go down, but will it go down a lot? Will it go down a little? Elasticity of demand allows us to measure it. And the formula for elasticity of demand, we use the Greek letter epsilon to represent the point elasticity of demand, is the opposite of the price divided by the demand times the derivative of the demand with respect to the price. So here, P is the price. That's a constant. And Q is the demand amount. So let's say that a company uses the following model to predict sales based on the price. We say that Q, the demand, is equal to 4,500 divided by the third root of P squared, where Q is the demand and P is the price. We are going to find the point elasticity of demand when the price is $27. First off, I'm going to take our Q function and make it into something that might be easier to take derivatives of by rewriting that function as 4,500 times P to the negative 2/3 power. The negative because it's in the bottom of a fraction, and the 2/3 because the index becomes the denominator, because this is going to make it easier to find the derivative of the demand with respect to the price. We've got this constant of 4,500. Bring the exponent out front of negative 2/3, and then decrease the exponent by 1. Subtracting 3/3 gives us negative 5/3. Doing a little bit of math then to simplify this, 4,500 times negative 2/3, that's going to be negative 3,000 P to the negative 5/3 power. Let's plug in our sales price then to figure out what the derivative is and the demand is at a price point of $27. So if the price is $27, Q at $27 is $4,500 times the 27 to the negative 2/3 power. My calculator can help with that. That's 500. So the demand is 500. The derivative of Q with respect to P at $27 is negative 3,000 times P, which is 27, to the negative 5/3 power. The derivative then is negative 12.35. We now have all the pieces we need to calculate the elasticity of demand. The elasticity of demand is the negative price, which is 27, divided by the demand. The demand we found out was 500, times the derivative, which was negative 12.35. So if we plug that into our calculator, the elasticity of demand is 0.67. In other words, a 1% increase in price will reduce demand by That's 0.67%. So it turns out that increasing our price by 1% has less than a 1% decrease in demand. So it's actually going to be beneficial for us to increase the price in this case. To summarize these results, if the elasticity of demand is less than 1, raising the price will actually increase revenue. So yes, we want to increase the price when the elasticity is less than 1. We call this inelastic because there's not going to be a negative impact on our revenue by increasing the price, not a significant reduction in demand. If the elasticity, though, is greater than 1, it turns out that raising the price will decrease revenue, because it might have increased the price by 1%, but decreased the demand by 2%. More decrease than increase. It's not going to help us out. We call this elastic, because the market is going to change sharply to an increase in the price. In these cases, when we're elastic, it's better to drop the price, which will increase the revenue. The other option is when that elasticity of demand is exactly equal to 1. That means raising the price has no impact on revenue. We want to keep the price the same. This is the ideal situation, because increasing the price will decrease revenue. Decreasing the price will increase revenue. We are at that perfect point. We call that unit elastic. So point elasticity of demand, it's simply the negative price divided by the demand times the derivative of the demand evaluated at that specific price point. If it's less than 1, we want to raise the price. If it's greater than 1, we want to drop the price. This can help us make many decisions in economics. It is your turn now to practice some of these applications of derivatives in business and economics on the assignment.